Good morning, everyone. Today we will see methods for solving recurrence equation. When you analyze the time complexity of algorithm, we are going to derive the recurrence relations. And when we solve the recurrence equation, we can find the time complexity of algorithm. So we are deriving recurrence relations for the given algorithm and how to find the time complexity and what are the methods available for solving recurrence relations that we will see today. And what's recurrence relations? We are writing algorithm for solving the problem. The algorithm time complexity can be analyzed using recurrence relations. So we are writing the mathematical equations to derive how the algorithm is executed. So it's called recurrence relation. The mathematical equations that can be described in the form of n and t. T represents time complexity. N represents input states, number of input to the algorithm. So one example is T of n is equal to T of n minus 1 plus T of n minus 2. That is time complexity of n is equal to time complexity of n minus 1 plus time complexity of n minus 2. So these are mathematical recurrence relations we are getting from the algorithm. So we have to solve these recurrence equations to find the time complexity. The general form of recurrence relation is a of n is equal to f of a n minus 1, a n minus 2. Like that, we will go when a of n minus k, the last term is n. So here n is input size, f is a function, and a is the term, nth term in the sequence. And f function that defines the relation between these two terms, t of n, t of n minus 1, like that. So K is the order of recurrence. This is an order in the mathematical functions. So this is a general form of recurrence equation. This can be derived from the algorithm. And we will see some examples for recurrence relations. First one is Fibonacci series. Fibonacci series is the problem to find the nth term in the series. That means the series starts with 0 and 1. 0 is the first term, 1 is the second term in the series. The third term can be calculated as a sum of previous two terms. That is, f of nth term is sum of n minus 1 and n minus 2 terms. So the relations can be derived as f of n is equal to f of n minus 1 plus f of n minus 2, where n should be greater than or equal to 2 because first two initial values are already derived 0 and 1. So it starts with 3, 2, more than 2. And here each term is sum of previous two numbers. This is Fibonacci series. So by seeing the relations, we can understand the process, what happened in the algorithm. And the second one is factorial sequence. Normally we know factorial. N factorial is n into n minus 1 into n minus 2 into n minus 3 up to 1 factorial. So that can be written as recurrence relations. For example, n factorial is equal to n into n minus 1 factorial. The next term will be n into n minus 1 into n minus 2 factorial. Like that, it will go till it reach the base case 0. So 5 into 4 into 3 into 2 into 1. If it becomes 0, algorithm will be terminated. This is the recurrence relations for factorial uh, sequence. And the tower of Hanoi problem. What is tower of Hanoi problem? There are n disks in one tower that should be moved to the destination disk using the intermediate disk. There are three criteria. Only one disk can be moved at a time. We can place smaller disk over the larger one, and we should not move more than one disk at a time. So this using these criteria, we have to move all n disk from one pole to another pole using the intermediate one. And so the relations can be T of n is equal to T of n minus 1 plus 1. So nth term time complexity is time complexity of n minus 1 term plus 1. So 1 is the number of movements. If number of disk is 1, only one movement of disk from pole source to pole destinations. So when the algorithm will be terminated, it's called base case. T of 0 equal to 0. There is no disk, no movement. So here n should be greater than or equal to 1. We need at least one disk. That is the recurrence relation for tower of Panay problem. And we will see binary search. T of n is equal to T of n by 2 plus 1. If in the first iteration n is input, that is number of size. Number of inputs, that is n is size of the input. For second iteration, size of the input is reduced by 2. That is 20 inputs for first iteration. Next input is 12, then 6, 3, 2, 1. So that is called binary search. T of n is equal to T of n by 2 plus 1. For each iteration, algorithm performs maximum on basic operations, that is called comparison. These are some examples for recurrence relations. And recurrence relations, there are two important parameters for recurrence relations. That is base case and recursive case. Base case ensures that when the recursion terminates, condition that specifies the value of recurrence for small input size. That is, when the input becomes small, the algorithm will be terminated. That is called base case. Recursive case, that is the algorithm will be executed for more number of input size. So recursive case is executed for more than one or one times. So execution starts from recursive case. When it reach base case, the algorithm will be terminated. And what is base case? Base case is a condition where the algorithm will be terminated. And this is stopping condition. So in the case of factorial, if n becomes 0, algorithm will be terminated. So n is reduced from n minus 1, n minus 2, n minus 3 till it reach 1. If it reach 1, algorithm will be terminated. If t of 0 is equal to 1. So the n value is 0, 0 factorial is 1. So n is 0, that is the base case. And recursive case example is a part of recurrence equation or recursive function where the problem expressed in terms of smaller instance. So that means the algorithm is executed more than once. And here, what are the characteristics of recursive case? It involves one or more recursive calls. It divides the problem into smaller subproblems. Recursive case is continued till it reaches the base case. For example, factorial. If n is 5, algorithm will be continued. N equal to 4, 3, 2. So these values of n is the recursive case. If n value becomes 0, algorithm will be terminated. 0 is the condition for base case. Greater than 0 is the condition for recursive case. And type of recurrence relations. So there are three types of recurrence relations: linear, divide and conquer, and homogeneous and non-homogeneous. What is a linear? It's a linear mathematical equations, that is linear combination of terms. N is n minus 1 plus n minus 2, n minus 3. This is a linear form of recurrence equations with respect to input size n. And what's divide and conquer? The problem size is divided. Problem is divided into number of subproblems. Can be two subproblem or can be three subproblems. That is, T of n is equal to a T of n by 2. The problem can be divided into a number of subproblems, and T of n by 2 is for each subproblem the size is by 2, by half or by 3, by 4. That is the case in this is one type of recurrence equations. It's mainly for divide and conquer approach. For example, quicksort, midsort, divide and conquer, convex hull. This type of problem will give you the divide and conquer recurrence relations. And third one is homogeneous and non-homogeneous. Homogeneous means depends on the previous term. Same pattern. T of n is 3 into T of n minus 1 or 5 into T of n minus 2. Like that, this is called homogeneous. Non-homogeneous means additional terms independent of the sequence. For example, T of n equal to T of n minus 1 plus n. So additional term added to the equations that will not make the equation as a homogeneous. When we add the new term, that will become a non-homogeneous. That is, example is T of n is equal to T of n minus 1 plus n. Example for recurrence relation is T of n is equal to 2 T of n by 2 plus n. This is non-homogeneous recurrence equations. The base case is T of 1. If n becomes 1, the algorithm will be terminated. Describes the runtime of algorithm. The problem is divided into two halves. 2 T of n by 2 means the problem is divided into two subproblems. Each problem can have the size of n by 2 inputs. By solving these recurrence equations, we are getting a time complexity of n is order of n log n. This is a time complexity for divide conquer algorithm. And what are the methods available for solving recurrence equations? There are four methods. First one is substitution method, master theorem method, recursion tree method, iteration or expansion method. Substitution method. So the recurrence relation is expanded to find a pattern. For example, n into n minus 1 plus n minus 2 or n cube plus n square plus n. So like that, we can find some common pattern when we expand the recurrence equations. That common pattern can be solved by finding closest form. Then after finding the closest form, we can find the summation. That will be very easy to find the time complexity. That is one type. That's called substitution method. Second one is Master's theorem method. So there are two concepts that in Master's theorem equations. It's mainly used for divide contour approach based algorithms. So T of n is equal to A T of n by B plus F of n. Here the problem is divided into two subproblems. That is A number of subproblems. A represents number of subproblems and B represents for each subproblem what will be the size of the input. So for example, n by 2 means every iteration size is reduced by half. Two subproblems having equal number of inputs. So 3 T of n by 3 means the problem is divided into three subproblems with one third of input size. That is plus f of n. That is maybe a non-homogeneous mathematical recurrence equations. So these type of problems can be solved or recurrence relations can be solved using Master's theorem. And recursion tree visualize and sum up the cost at a recursive level. The recurrence relation is converted into recursive tree. Tree contains root node and number of levels. So each iteration is represented as a level. So here the time complexity of or cost or maximum number of basic operations is calculated at each level. Finally, the cost is added of all levels to get the overall time complexity or cost of the proposed algorithm. And this is a visual representation of recurrence equations to find the time complexity. And iterations are expansions method. Iteration means set of statement is executed continuously or repeatedly. Let's call iterations. Example, looping statement, for loop, while, do while. These type of statements can be derived using iteration or expansions method. The first one, substitution method or base and verify method. It provides using mathematical induction. So initially the value can be guessed and that answer is substituted in the relations to verify the result whether the correct result or not. That's called substitution method. And this is a Master's theorem method. It's a powerful tool for analyzing recurrence equations to determine the time complexity of divide contour algorithms. The general form is T of A is equal to A into T of n by B plus F of n, where n is number of subproblems, P is the size of subproblem in each iterations. Um, so here the function is f of n is asymptotically positive functions. A and B are greater than or equal to 1. So there is a positive functions. And recursive tree method, the recurrence relation is converted into recursive tree. Here the root node represents the starting place of the execution. Each node represents the cost at each level. So there are multiple levels in recursive tree. The cost at each level is calculated, and finally the cost of all levels are added to get the uh, total cost of the algorithm or time complexity of the algorithm, mainly used for solving time complexity based recurrence relations. Steps: first, convert the recurrence relations into recursive tree. Each node represents the cost taken by various level of recursions. And finally, calculate the cost at each level and find the number of levels in the recursion tree. Sum all the work done at all levels to find the complexity of overall algorithms. Iteration method approach. Iterations refers to the repeated execution of block of code, often within a loop to achieve a desired outcome. To analyze these types of algorithms, iteration method is used, mainly used for solving looping statements and for loop while loop statement until it reach the termination conditions. Thank you.